So we are going to be going over how to do this dimensional analysis technique. So what we're going to need to do here first is demonstrate that it's awkward to cancel out units when they're written like 1 through 10. So check out number 1, grams over moles. It's not easy to see this, but it's 1 over moles. And then moles ends up flipping up to the top. So that's difficult. And this whole side is not easy to figure out what the final units are. So I'm just going to cross out 1 through 10, and we're going to skip over to a little bit of practice with just how you cancel out units. This won't make a lot of sense right now, but once we're actually doing the problems, it will. So I'm going to slash with a highlighter because it's more fun. Anytime you see something that's the same on the top and bottom, it's usually in a diagonal like this, you get to slash them out. And then look at what you're left over with. In this situation, it's moles. So those are the remaining units. So let's look at number 12. You don't get to slash anything out because there's not anything that's on the top and the bottom. So something probably went wrong with this problem because it's moles squared over grams, and those don't seem like very useful units. They aren't. Let's look at number 13. You've got moles over moles, and you're left with grams. Oops. Number 14, another weird one. Grams times grams is grams squared over the moles. So that means something probably went wrong. 15, we can do some canceling. Grams over grams, moles over moles, and we're left with molecules. Number 16, inches over inches, feet over feet, and we're left with miles. Number 17, something doesn't look right here. We are able to slash out hours, but we're left with days squared over seconds. So sometimes you know you do the problem wrong, just based on your units not working out. And then let's look at our last one here. Centimeters over centimeters, inches over inches, feet over feet, and miles over miles. We're left with marathons. So those are resulting units here. Alright, let's actually use this technique with a problem with numbers. So you use conversion factors in dimensional analysis. This is something like 1 inch is equal to 2.54 centimeters. That's a conversion. So notice I wrote the equal sign sideways. When you do these problems, like number 1, when we start this, convert 94 millimeters to inches, we always start by writing the number and the units that you're given. If it's interesting, like miles per hour, what that's saying is miles per 1 hour. So you have a top and a bottom. Then once you have everything written out, you'll see what I mean. You multiply everything on the top, you multiply everything on the bottom, and then you take the top divided by the bottom to get your final answer. And you do that slashing technique to figure out what units are left over at the end. So let's do these together. First one, 94 millimeters. Draw a line underneath it. We want to get this into inches. So let's see what we've got. If I go up here, I see that 10 millimeters are in 1 centimeter, and I see a conversion from centimeters to inches. So, okay, I know that I want millimeters to go on the bottom because I want those to cancel out. So I can write 10 millimeters is equal to 1 centimeter, and if I stopped right here, I could multiply across the top, divide by the bottom, and I would know how many centimeters I've got. But I'm not going to stop because I want to get centimeters into inches. So I know that I want centimeters on the bottom because I want them to cancel out here. So the other conversion unit was 2.54 centimeters is equal to 1 inch. So now centimeters are going to cancel out, and I'm going to do 94 times 1 times 1 divided by 10 times 2.54. That comes out to be 94 divided by 25.4, which ends up being 3.7, and then look for the only units that aren't canceled out, inches, and double check that that's what the problem asked for, which it did. Now you might be saying, I don't need to use this technique. I can do this in my head. I've done this kind of conversion before. But later on, when we get to long stoichiometry problems, you're going to want to use this technique. So just go with it for now and trust me. Number 2, 5.1 meters. If we want to get this into feet, there are a couple ways we can do this. But I want meters to cancel out, so I'm going to write meters on the bottom. And I found a conversion that 1 meter is equal to 39.37 inches. So now I want to get rid of inches. I know that there are 12 inches in 1 foot, so now inches will cancel out, and I'm going to multiply everything on the top divided by everything on the bottom, and this comes out to be 17 feet. What about number 3? 34 meters for every 1 second. What if we want to convert this into miles per hour? Well, let's start with the meters. There are 1,000 meters in 1 kilometer. So meters cancels out. There are 1.6 kilometers in 1 mile. So if I stopped right now and multiplied across the top and divided by the bottom, I would have my units in miles per second. But I don't want that, I want miles per hour. So now I need to get rid of seconds, so I need to write them on the top. I know there are 60 seconds in 1 minute, so seconds can cancel out here. And then I want to get rid of minutes, and I want to get into hours. There are 60 minutes equal to 1 hour, so minutes cancels out. So now I've got miles over hours. I'm going to multiply everything on the top. That's 34 times 60 times 60, which is 122,400 divided by everything on the bottom. 1 times 1,000 times 1.6. That ends up being 1,600. Top divided by the bottom is 77 miles per hour. Last one here. I recommend pausing the video and trying to do this on your own. 5 days into seconds. 1 day is 24 hours. 1 hour is 60 minutes. 1 minute is 60 seconds. Minutes cancel out. Multiply everything across the top, divided by 1 in this case, comes out to 432,000 seconds. So that's how you do dimensional analysis.